Welcome to 4.2, Rolle's Theorem and the Mean Value Theorem. Today, you as students will be able to use the Rolle's Value Theorem, and you'll also be able to understand and use the Mean Value Theorem. So, two quick theorems to learn by the end of today. Let's see how you go. So, first off, why don't you guys start with what you do now, 4.2a, see how you guys handle this one. You're finding the relative extrema. That means you're finding the maximum and minimum point in this function. So, in order to do this, if you pause it, unpause it, first step would be to find the derivative. 4 times 1/2 is 2. 4 minus 1 is 3. 5 times 3 is 15. 3 minus 1 is 2. 2 times 4 is -8. 2 minus 1 is 1. And the derivative of 7 is 0. And it all equals 0 because you said it equals 0. You're just using the power rule to find the derivative, which is the derivative of x to the n equals n to the n times x to the n minus 1. Now, you're going to have to take out something here. You're going to take out a, can't take out a 2, you're just going to take out an x, all right? So, you're going to set this and this equal to 0. Now, in order to set the second part equal to 0, you're going to have to factor it. Now, the way you should have factored it, factors of 2, multiplied by factors of 8. Factors of 2 are 1 and 2. Factors of 8 are 1 and 8, or 2 and 4. So what you did here was you set up your problem, and in class we did this with the big board. 2 times x is 2x squared. 2 times 8 is 16. 16 minus 1 is 15. All right? And then -1 times 8 is -8. X equals 0. 2x minus 1 equals 0. So you add 1 to both sides and divide by 2, and x equals 1/2. X plus 8 equals 0. So you subtract 8 from both sides, and x equals -8. All good? So these three things are your critical numbers. Okay, now in order to find the critical points, that's your extrema, is the points, you take these three x values. Do you remember what to do? When I point, yell at your answer. Exactly, plug them into the original equation. So half of 0 to the 4th plus 5 times 0 to the 3rd minus 4 times 0 squared plus 7 equals 0, 0, 0 plus 7 is 7. So our first point is 0, 7. And it doesn't really matter the order. Usually you go from the value all the way to the left to the right on the graph. Next one, I just gone through these. 1/2, all right? So when I do 1/2, type it in my equation, you get about 6.65, 625. So you want to just round that probably to like a 6.66 or a 6.7. So it's 0.5 or 1/2, 6.66. All right? I like to round things to the 100th place. Shows I'm being accurate. -8, plug it into the original equation. It spits out an answer of -761. And that's your last point. -8, -61. Boom, boom, boom. The order you probably should have went in though was this point, that point, that point. Just because, like I said, usually go left to right. We'll be doing that later when we do increasing, decreasing functions. Got it? So see, you did learn something last lesson. Now what we're going to do is we're going to jump right into something called Rolle's Theorem. Now, this theorem is pretty helpful. It says, let f be continuous on the closed interval, a, b. All right? There's your closed interval from a to b. So we're just dealing with the stuff above this graph. All right, and be differentiable on the open interval a, b. So that means you can take the derivative for everything in between a and b. If, now here's the key, f of what equals f of what? Let's see, f of a, good, equals f of b, good. Whoops, where's my b? There it is. Then there's at least one number c in a, b such that f prime c equals 0. What does this prove? A lot of words here, right? So what this actually proves is between the, what are these things called? X-intercepts, right? There is at least one something. Think back to the do now. Extrema. All right, so what that means is between every two sets of X-intercepts, there's going to be at least one extrema. And what we're going to do is we're going to be able to find that extrema. There are 4 simple steps I broke down in order to do this. This is based on the book, but I'm trying to make it a little simpler. So, the reason for that is f prime c equals 0, okay, or to be undefined. Now the reason it's 0 is because the graph goes from increasing to decreasing. So if I'm going to go, or if I go from decreasing to increasing, right? So in order to go from an x-intercept back there, if I go up, I have to go back down to get there. If I go down, I have to go back up to get there, right? And remember, this is only if it's a continuous. That's when the f prime c equals 0. So first step, you're going to factor. Whatever my equation is, I factor the equation. All right, that seems pretty easy, right? What do you think after you do after you factor it? Good, you solve for x. So this is like my first step, factor the equation, solve for x. And when you do these two steps, what you're actually doing is just finding the x-intercepts, okay? So step 1 really could be find the x-intercepts. To do that, you factor, solve for x. What do you think step 3 is? I'll give you a hint. You're going to set f prime x equal to 0. Look familiar? What do we do after we do that? Solve for x again. You find your critical points, you solve for x, take that x, plug it into the original equation. So steps 3 and 4, what do you think they do? They find your extreme. Okay, so in order to do the Rolle's theorem, first thing you do is find the x-intercepts, then you're going to find the extreme. Easy enough, right? Let's see. Now let's do the first problem. Find the x-intercept and the critical points of f of x equals x squared minus 3x plus 2. First step, factor, solve for x. You guys can all do that. All right, just remember, if this is a positive, the signs are the same. If this is a negative, the signs are different. So when I factor that, I'm going to find my x-intercepts. Factors of 2 that add up to 3. Well, there's only 1 and 2, right? So since this is a negative, it's not minus 2, minus 1. Negative 2 minus 1 is negative 3. Negative 2 times negative 1 is 2. Always check your answer. And you're going to set that equal to 0. So step 1, factor. Step 2, set equal to 0. When you solve for x, x minus 2 equals 0. X equals 2. And then x minus 1 equals 0. Add 1 to both sides and x equals 1. Right? So you plot your points. I plot my 2. And I plot my 1. And these are x's, so they go on the x-axis. Remember, y-axis, x-axis. Any questions yet? That was pretty easy, wasn't it? Step 3 and 4, you're going to set the derivative equal to 0 and then solve for x there. So, what's the derivative of x squared minus 3x plus 2? 2x minus 3, right? Solve for x. Add 3 to both sides. Divide by 2, and x equals 3 halves, or 1.5, 1.5, right? How do we find the critical points? Well, there is only one, because there's only one critical number. We take this 3 halves, so what do we do with it? Good, we plug it back into the original equation. So 3 halves squared minus 3 times 3 halves plus 2. You can use 1.5 as well. And that gets you, if you use this and do this in your head, 3 squared is 9, 2 squared is 4, minus 9 over 2 plus 2. 9 over 2 becomes 18 over 4. 9 minus 18 is negative 9 over 4 plus 8 over 4. So negative 1/4. All of that. See? You can do it all in your head. Or use a calculator. 3 halves, so 1.5, down 1/4. 1.5 down 1/4. Sorry, I was going through the wrong things. Each one of these dashes counts as 1. So look at it. There's my graph. That wasn't too hard, was it? X-intercepts. Extreme. Alright? I want you guys to attempt problem number 2. Go. Do the whole thing. See if you can do it. See if you missed class. Don't you feel like we're back in class? You do this all on your own. Factor. So, x squared minus 5x plus 4. Factors of 4 go to negative 5 is negative 4 and negative 1. Set them both equal to 0. X minus 4 equals 0. X minus 1 equals 0. Add 4 to both sides. X equals 1. Add 1 to both sides and x equals 1. Did I say 1 there? 4 and 1. Jumping ahead, my brain short-circuited. Alright, so next step. Step 3 and 4, set f prime x, so you take the derivative of this. You get 2x minus 5. So I'm going to plot these points. X equals 4, x equals 1. Now I'm going to derive, and you can plot at the end if you want. Add 5, divide by 2, and you get 5 over 2, or 2.5. Take the 5 halves, plug it into the original equation. 5 halves squared minus 5 times 5 halves plus 4 is negative 9 over 4. This is 25 over 2 minus 25. 25 over 4 minus 25 over 2 plus 4, and you get negative 9/4. So you can also say this is 2.5, negative 2.25. I like to use decimals better because it's easier to graph that way. So 2.5, 1, 2.5. 2 1/4 down, 1, 2 and a little bit down. Answer's here. Connect your points. And once again, you got A. What do you got? Parabola. All right, now the reason you go through these points and you don't go back down is we only have one extrema. So if these were going to go back down, only if these two numbers on the x-intercept were extrema as well. Because they're not, we only have one. This is the only point where I go from decreasing to increasing or increasing to decreasing. Got it? See? It's almost like a class already. All right, try problem number 3. Flying here today. It's easy. All right. Kind of went a little bit different. Now there's values, and I kind of merged the rules here. So find x-intercept, find critical points. Now there's a new rule here, find the endpoints. Because we're on an interval, -2, -2, interval, because you have brackets here, remember, and it says on the interval, so these are both x values, you have to plug them into the equation too to get the actual points. So we're going to graph this equation based on this information and based on this. So first thing, find the x-intercepts. Be able to do that. You could pull out a what? X squared. So when I pull out x squared, I'm left with x squared minus 2. You're going to set them both equal to 0. When x squared equals 0, x squared minus 2 equals 0. Square root of 0 is 0. I'm going to add 2 to both sides. Is max equals 0. Add 2 to both sides. And the square root of 2 is plus or minus square root of 2, which is plus or minus 1.41. So 1 and almost a half, -1 and almost a negative half. Got it? Whoops. Plus or minus radical 2, plus or minus 1.41. Next thing, we have our endpoints. These are x values, so to find the y values, -2 gets plugged into this equation. -2 to the 4th power is 16. Minus 2 times 4 minus 8 is 8. So -2, 1, 2, and then up 8. I plug 2 into the equation. 16 minus 8 is also 8, so our other endpoint is 2 over 8 up. Now we almost got our graph. Right now it would be like, that's not right. We need to have some either points that pop up here or pop up here between them. We need the critical points. So you derive that. Derivative is 4x cubed minus 2x. So this is, minus 4x. Oh, no big deal. All right, what do I pull out? I pull out a 4x, x squared minus 1. 4x equals 0. X squared minus 1 equals 0. Divide both sides by 4, x equals 0. Ooh, and then add 1, and square root of 1 is plus or minus 1. So we actually have 3 critical points here. Interesting. So let's go. We got x equals 0. So we plug in 0 into our original equation, and that point is 0, 0. I'll put that point right there. Next thing we do, we're going to take a -1. Plug it into this equation. 1 minus 2 is -1. So, -1 is a point right here. Oops, where are we at? And then we're going to take +1. 1 minus 2 is -1. +1. -1 is our 3rd point. So those are our 3 points. Remember, we just took these 3 things and plugged them into this original equation. Put our 2 points here. Now, all you have to do next is connect the dots. Always connect from left to right because it's easier, and go through all the pieces. That one, there, 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 up, up. When you get to a blue, you switch directions. So you go from down to up to down to up, and you go through it. And there's our equation. Notice these things are not arrows because these are endpoints, and that's where our graph stops. If it was to go on forever, it would just shoot through there and extend with arrows. Got it? See? Alrighty, try number 4. Now, here's a hint for number 4. X-intercepts, there really is no work to do. You're just going to set these 3 things equal to 0. So x minus 1 equals 0, x equals 1. X minus 2 equals 0, add 2, x equals 2. X minus 3 equals 0, x equals 3. Plot your points. 1, 2, 3. 2, 3. All right, now, in order to derive this, what do we have to do? Do we have to do 2 product rules? No. You have to foil first. So, first step is you want to expand this. So this is where it becomes a little annoying. So the way to expand this is you foil. x squared minus 2x minus x plus 2. So this becomes x squared minus 3x plus 2 when you multiply these two together. And then you're going to have to distribute the negative, the x minus 3 into that. So this becomes x cubed minus 3x squared plus 2x minus 3x squared plus 9x minus 6, which when I combined all the like terms gives me x cubed minus 6x squared plus 11x minus 6. Now this is just expanding this. All right. Now the reason you do that is now you could take the derivative easily. 3x squared minus 12x plus 11 equals 0. Now unfortunately, there is no factors of 3 and 11 that when you multiply and add them together give you negative 12. So you have to use your quadratic equation. We went over this before, but those of you guys forgot. Whatever's in front of your x squared is your a. Whatever's in front of your x, the negative 12 is my b. And whatever is with no variables is my c, so that is 11. So a, b, and my c. I'm going to plug it into this equation. Negative b plus or minus negative b squared minus 4 times a times c over 2a. Now, here's the key to this problem when you solve it. Make sure the negative's out front here. Negative 12 becomes a positive 12. When you square b, if b is negative, make sure you put that number in parentheses. So negative 12 squared is 144. Don't put negative 12 squared in your calculator. Put open parentheses, negative 12 close parentheses squared, or else it's going to mess up the sign and ruin your problem. So 144 minus 12 times 11 is 132. All right. So 12 plus or minus square root of 12 over 6. So now what you do, very simply, 12 plus square root of 12, enter, divide by 6, 1.42. 12 minus square root of 12, enter, divided by 6, gives you 2.56. Oh, wait, sorry. This was the minus, this was the plus. All right? These are my two critical numbers. What do I do with these numbers? I take them and I can plug them into either one of these equations to solve. All right, I like to do it into this one because I can do it in my head. Like I can go, okay, 0.42 times negative 5.8 times negative 1.58. But it doesn't matter. When you plug it into either one of these, you get 0.38 as an answer. When you plug 2.58 into either one of these, you get negative 0.38 as an answer. So about 2.5. Right, 1.4, 0.4 about, and then you go about negative 2.6, 1, 2, 2.6 is a little bit more, minus 0.4 is right here, right, your graph, looks like that, almost like a sine curve that ends up going forever, or a cosine curve, little crush that's going forever, right? You good? That wasn't too bad, was it? All right. Do now 4.2b. Go. This is just a factor. All right. I threw a bunch of factor lessons in here because all my classes that I go through typically have this problem with factoring numbers that don't have just an x squared. So factors of 3 are 1 and 3. All right. So we have x plus something, 3x plus something because these are both pluses. Factors of 20, 1 and 20. So watch this, 1 times 1, 3 times 20. If you add these together, you get 61. Is 61 equal to 17? No, so we will not use 1 and 20. What is another set we can use? How about 2 and 10? 2 times 10 is that. So 1 times 2 plus 3 times 10. 2 plus 30 is 32. Any other factors of 20? Well, 4 times 5 is 20, right? 1 times 4 plus 3 times 5. 4 plus 15 is 19. Oh, we're almost there. We're getting there. Any other factors? 5 and 4. Now you just start doing all these backwards. All right? 5 times 1, 3 times 4. 5 plus 12 is 17. Bingo. We hit the numbers we need. All right? If I were to keep on going and say I flipped the 10 and 2 and the 20 and the 1, and you went through, you'd get 26 and 23. Our goal here is 17. So what this means, okay, this is the key here. 1, which is your x, times 5. It has to be multiplied by 5, the number 5. So if x is here, 5 has to be in the opposite function. The 3 has to multiply by the 4. So if the 3 is here, your 4 has to be in the opposite function, not the same. Now watch what happens. 3x squared plus 5x plus 12x plus 20. And that's your answer. 3x squared plus 5x plus 12x plus 20 is 3x squared plus 17x plus 20. Bingo! And then you factor. Alright? So our factor is x plus 4, 3x plus 5. Whoops. Good? Alright. Ready to move on? Alright. Whoops. That was virtual classes. Gotta get rid of that. Oh, it all started. Alright. Problem number 5. Ready? Negative x squared plus 3. Find the x-intercepts. Alright? So, solve these two problems. Find x-intercepts, find critical points, and graph. Good? Alright, find the x-intercepts. Take out a negative x, or just take out an x, it doesn't matter. X equals 0. Negative x plus 3 equals 0. X equals 3. So you got 0 and you got 3. Find the critical points, derive that. Negative 2x plus 3. Subtract 3, divide by 2, and you get negative 3 halves. Take your negative 3 halves. You get positive 3 halves. Negative 3 halves squared is negative 9 over 4 plus 9 over 2, and that gives you 9 over 4. So you go 1 1/2, and you go 2 1/4. Pretty point. That's a big quarter, but it's about a quarter. And then you put your graph. Got it? Awesome. Let's go to 6. I'm going to pop over here. Oh, I haven't been here in a while. All right, so intercepts, that both these equal 0. X minus 3 equals 0. X plus 1 squared equals 0. X equals 3. X what? Plus 1 equals 0 because the square root of 0 is 0. And then you subtract 1 from both sides and x equals negative 1. So you got 3 and you got negative 1. You have to expand this, remember? So you're going to do the squared first. So x plus 1 squared, x times 1, x plus 1 times x plus 1 is x squared plus x plus x plus 1. That's where you get the 2x from. Distribute the x minus 3 in there. X cubed plus 3x. X cubed plus 2x squared plus x minus 3x squared minus 6x minus 3. Combine like terms. And you get x cubed minus x squared minus 5x minus 3. Derive this. 3x squared minus 2x minus 5 equals 0. Now, to use the quadratic equation, you don't have to. You can actually use our rule. Factors, you can go 1 and 3 here, and then you can go 5 and 1. So, 3 times 1, 5, negative 5 times 1. Because this is a negative, we use opposite sides. So, negative 5 plus 3 is negative 2. Set these both equal to 0. 3x minus 5 equals 0. Add 5 divided by 3, and you get x equals negative 1.7 about, positive 1.7, about 5/3. Alright, you plug that into this equation right here. You get negative 9.5. 5/3, negative 9.5. You're going to put x plus 1 equals 0, subtract 1, x equals negative 1. Negative 4 times 0 is 0. Negative 1, 0 is right here. Oops, sorry. Oh, what does that mean? Well, now look, since this is on the intercept, this means I'm going to go, so you don't know, well, we can't do that because we have to go from here to here to here, right? So that means since this is like this, at this point, what do I have to do? I have to change directions, right? Because it's an intercept, and which way do I go? Back down. This one extends up here forever, and this one's going to have to switch directions and go back down. The reason this one goes through this, intercepts, you pass through. If it's an intercept and an extrema, when you get to it, you change direction and go back down. Got it? So this would be our graph. Good. All right, let's go do some more problems. All right, problem number 7. All right, now, this problem, what are we going to put in here? Yeah, you're right. Quotient rule. So, first thing, when you find the x-intercepts, what you guys should always know to do is you set the what equal to 0. Numerator equal to 0. So I factor the numerator, x minus 3x plus 1, and then I'm going to take the denominator. When I set that equal to 0, what does that give us? What happens when this graph is x equals negative 2? Negative, it becomes a 0 on bottom, and our graph is undefined, meaning we get what do we get? A vertical asymptote. Anytime your denominator is set equal to 0, when you have a fraction, it's undefined, which is your vertical asymptote. So at negative 2, you have a vertical asymptote, which is not on my graph. All right, so that doesn't matter. Why isn't it on my graph? That's weird. All right. Anyway, intercepts here. Negative 3 and 1. You said that both equal to 0. X equals 3. X equals negative 1. All right. So right here, this dot, if it's a little bit further, there'd be an asymptote. All right. Critical points. We have to use our quotient rule. F is your numerator, x squared minus 2x minus 3. G is your denominator, x plus 2. 2x minus 2 and 1. F prime g minus g prime f over g squared. 2x minus 2 times x plus 2 minus 1 times all that stuff over x plus 2 squared. Distribute 2x squared plus 4x minus 2x minus 4x minus x squared plus 2x plus 3. Combine like terms. 2x squared minus x squared is x squared. 4x minus 2x plus 2x is 4x. Negative 4 plus 3 is negative 1 over this squared. So we're going to do two things. First thing we're going to do is set it equal to 0. Okay, remember to find a critical number, you set it equal to 0, you set it equal to undefined. So I have to factor the numerator. In order to factor the numerator, hopefully you used your quadratic equation. I told you this question was a tough one. So, negative b plus or minus b squared minus 4 times a, which is 1, because there's nothing there, times negative 1, which is c, over 2a. All right, now, the bottom doesn't mean anything because we're just setting the top equal to 0. Negative 4 plus or minus the square root of 16 plus 4 is the square root of 20 divided by 2. So negative 4 minus square root of 20 divided by 2 is 0.24. Plus square root of 20 divided by 2 is 0.24. Negative 4 minus square root of 20 divided by 2 is negative 4.34. We're going to take both these numbers and do what with them? Plug them into the original equation. All right, now, why is negative 4.34 not good? Why do we have to use that? Forgot to tell you about this. That's why I never put my asymptote. What is negative 1 to 3? That is my interval, right? So anything that's not between these 2 points, which just so happens to be these, we don't care about. So we don't care about this number over here right now. We care about it later. So we just take our 0.24, plug it into this equation, and we get negative 1.5. All right? We set the bottom equal to 0 as well, because when f prime x is undefined, x plus 2 squared equals 0, square root of 0 is 0, and x equals negative 2. Now, negative 2, does that fall in this interval? No, that's where the asymptote is, right? But it doesn't fall in this interval, so we don't care about that either. So the only thing we care about is this little graph, because that's the part that's in this interval. All right, if we kept on going, okay, what would happen here is this would just extend this way. This would extend here, and there's an asymptote at 2, all right? Negative 4.3, so negative 4.3 over there somewhere. That's off the screen, all the way over there. What would happen is the graph would probably go change direction as well. Probably be like some type of thing like that. Got it? Okay. Try problem number 8. Now I took off the intervals here. Throw intervals on sometimes, take them off sometimes, so you got to be careful to watch. Set the numerator equal to 0, subtract 1, square root of 1, negative 1, is I, right? We don't deal with i's in calculus, multivariable calculus, maybe. So x equals undefined. So what does that mean about intercepts? There are no intercepts, okay? X equals 0. When it's undefined, x equals 0. So what happens at 0 here? We have a vertical asymptote. Very good. Draw that little vertical asymptote on there. That's the dashed line, in case you guys forgot. All right. Derive this now. What do we have to use? Quotient rule. So, x squared plus 1, x, 2x, 1. All right. 2x times x minus 1 times x squared plus 1 over x squared. 2x squared minus x squared minus 1 over x squared. We cannot take an x squared out of here because there's none right here. But we can factor this top. Factor the top to be, not factor, we could combine like terms, sorry, word mess up. 2x squared minus x squared is x squared, minus 1 over x squared. Once again, you cannot just cancel these out and make these ones, all right? But you can factor this, x squared minus 1. That's a perfect square, so this becomes, do we need to factor it? Well, when x is 0, when f prime x is equal to 0, the numerator equals 0. So you can either make this x plus 1, x minus 1 equals 0, or just add 1 to both sides and square root of it, and you get plus or minus 1. Either way gives you the answer. Take these ones, plug them in here. 1 plus 1 is 2. Divided by negative 1 is negative 2. 1 plus 1 is 2. Divided by positive 1 is positive 2. So 1 positive 2. Negative 1, negative 2, 1 positive 2. Notice the units go by 2 left to right, and they go by 1 up and down. Set it equal to undefined when the bottom is equal to 0. So when x equals 0, what's at 0? It's a vertical asymptote at x equals 0, right? So it doesn't matter. So what in the world do you think those graphs look like? They change from increasing to decreasing at these points, right? However, they can never cross the x-axis. Do you guys have any idea what these graphs look like? Like this? No, because that would stay increasing and decreasing. How about a little parabola up and a little parabola down? Got it? All right, try problem number. Homework one. Go. Or you should have done this one actually. Go to homework. I'm breaking my point. All right, so first thing, find the x-intercept. Set the numerator equal to 0. Add 9, divide by 4, you get 9 fourths. Square root of 9 is 3, square root of 4 is 2. So it's plus or minus 1.5 or plus or minus 3 halves. Vertical asymptote is when the new denominator equals 0. So you got minus 1.5 plus 1.5. X cubed equals 0. So cube root of 0 is 0. So you have a vertical asymptote right there. Good so far? Critical points. Quotient rule again. Never get rid of that quotient rule. F, G, 8x plus minus 0, and 3x squared. F prime G, G prime F over G squared. 8x times x cubed minus 3x squared times 4x squared minus 9 over x cubed squared. 3 plus 1 is 4. All right, so that's 8x to the 4th minus 12, x to the 4th, plus 27x squared. 3 times 2 is x to the 6th. What can we take out of this problem? They all have an x squared in them, right? So we can take out this whole x squared. Well, actually, we'll combine like terms first. It doesn't matter what order you do it in. 8 minus 4 is negative 4x to the 4th plus 27x squared over x to the 6th equals 0. All right, so when f prime x equals 0, you could set the whole top equal to 0. You could have took the x squared out, didn't matter. Because watch, we're going to do it right here. Take the x squared out. Actually, yeah, I guess you should leave it in. But like I said, it won't really matter in the end with this answer. X squared equals 0. Negative 4x squared plus 27 equals 0. So that's your vertical asymptote we already found out, right? Subtract 24, divide by negative 4, and square root of this is about plus or minus 0.26. So, take plus 26, plug it in here. Take minus 0.26, plug it in here. You get his answers, negative 1 and 1. So negative 2.6, negative 1, 2.6, and 1. All right, still following me? Can you figure out what we're doing yet? All right, when undefined, when x to the 6 equals 0 and x equals 0, which is your vertical asymptote. So what in the world does this graph look like? Anyone? This is a tough one. Now the problem here is it has to go through this point, so it has to come here. And when it comes here, it has to increase, but it can't cross this line again. And it can't go through here. So your graph actually looks like that. It comes down here, and there's actually a horizontal asymptote at 0. And this graph looks the same way. It comes up through here, comes there, and then hugs it the other way. You will find out shortly how to actually solve those problems. All right? A little tricky. One or two you guys probably got it though. All right, so let's move on to the do now problem. About a halfway point, so we're doing good here. All right, X-Intercept. You're going to set it equal to 0. You're going to add 1 to both sides. This is the same as x squared, the cube root of x squared minus 1 equals 0. If you want to write it in this form, I would suggest so because it just makes it easier to solve. Add 1. When you cube 1, you still get 1. Square root of 1 is 1, so it's plus or minus 1. All right, so 1, negative 1. Endpoints. Take your two endpoints, plug them into the original equation. All right, negative 8 squared is 64. Cube root of 64 is a number. That's 4. 4 minus 1 is 3. So negative 8, 3. Negative 8, 3. Plug 8 in. 8 squared is 64. Cube root of 64 is 4. 4 minus 1 is also 3. So you got 8, 3. Boom. All right, so we're going to go here, maybe here. I don't know what we're going to do yet. We got to find our critical nut points. Derive that. Derivative of this is 2/3 x to the negative 1/3 minus 0. You're going to set this equal to 0. Now, x to the negative 1/3 means the cubed root of x, and because it's negative, it will be in the denominator portion of the graph. So 2/3 x to the negative 1/3. If we multiply both sides by the reciprocal, which is 3/2, you get x to the negative 1/3. And like I said before, x to the negative 1/3 is the same as 1 over cubed root of x. All right. Now, here's where we get some trouble. If I want to try to solve this, when does this ever equal 0? Think back to domain and range. Never, because there's no variable in the numerator, so it's never going to be 0. So there are no critical points based on setting this equal to 0. Now, when is this undefined? We can use the same answer over here. It's going to be undefined when the denominator is equal to 0, right? So that's when our answer is 0. Now, can we actually find when it's 0? If we plug 0 into the original equation, 0 squared, the cube root of 0 squared is 0. 0 minus 1 is negative 1. So our point is 0, negative 1. 0, negative 1. So watch this. Take this, do the point, back up, and there's our graph. Good? Awesome. Let's move on. Factor. Let's see if we can get some factors. There's some factor problems on all the time. Don't think we're just going to leave this because I'm going to assume you know it. Hello. All right. Factors of 2 are 1 and 2. Factors of, so you got x and you got 2x. Factors of 15. And it's negative, so one has to be negative, one has to be positive, okay? Negative 1 and 15 we'll start with, and you can start with whatever you want. 1 times negative 1 plus 2 times 15. This is negative 1 plus 30 is 29. No good. Let's try another one. 1 and 2x, negative 3 and 5. All right? Negative 3 times 5 is negative 15. So negative 3 plus 10 is 7. No good. All right? Now let's try negative 5 and 3. 1 times negative 5, 2 times 3 is a positive 1. There we go. We found our answers, negative 5 and 3. Now if I tried, say, negative 15 and 1, I would have got 13. No good. because we wanted 1. Now, say you got one of these answers, but the sign was wrong. All you would do is just flip the sign on these two. All right, so you don't have to do it with every sign. So, 1 has to multiply by -5, 1. This has to be -5. 2 has to multiply by 3, 2 and 3. So instead of plus and minus, you get x plus 3, 2x minus 5. Good? All right, let's go with B. 1 and 5, factors of 3 are 1 and 3 are 3 and 1, right? 1 times 1 plus 5 times 3. 1 plus 15 is 16. Well, we hit it right off the bat. If we went the other way, we get 8, so that's no good. So you can do it both ways. So we're going to obviously use the top piece. 1 has to multiply by 1, x times 1. 5 has to multiply by 3, 5x and 3. Hopefully you're getting this a little bit better. Practice a bunch of stuff. Go to Khan Academy. Go get some worksheets. You have the whole interweb to use. All right. Now let's go do some trig. Oh no, my thing messed up here. That's supposed to be that graph. I don't know what happened to my thing messed up. All right, so anyway, X-Intercept here. And typically in class, we probably skip this, so this is like an extra bonus lesson. So 0, this is your sine intercepts, because we're going from 0 to 2 pi. Pi, right? And 2 pi. Those are my 3 X-intercepts. My critical points. Well, the derivative of sine is what? What's the derivative of sine? 0, pi, 2 pi. Derivative of sine is cosine. So when does cosine x equal 0? At 1/2 pi and at 3/2 pi. All right? I'm just using these graphs to figure this out. Put 1/2 pi, sine 1/2 pi is 1. So 1/2 pi, 1 is my answer. 3/2 pi, sine of that is -1. So 3/2 is -1. And look what you get here. There's your graph of sine. I know we took the graph of sine to find the graph of sine, but you got it. All right, so we're just going to use the same graph over here. Like I said before, computer had a problem right here. All right, so anyway, X-intercepts. Well, you would see the X-intercepts of cosine are 1/2 and 3/2 pi. All right. Let's put dots on nothing. So the critical point of cosine is negative sine. All right. So negative sine would just be this thing upside down. You can also divide both things by -1. So when does sine equal 0? As we said before, 0, pi, and 2 pi. All right. 0, pi, 2 pi. Just based on this, backwards. It would have been right here. And then, what do we got? Plug them in. 0, 1, negative pi, and 2 pi. Got it? And there's our answer. All right. Sorry. All right, problem number. That completes Rolle's theorem. Now we're on to mean value theorem. So, way to start very simple. If f is continuous on the interval AB and differentiable on the open interval AB, then there exists a number C in AB such that the two things are true. First thing, f prime C equals f of B minus f of A, all right, the function of B, the y value of B minus the y value of A, divided by the x value of B minus the x value of A. All right, A and B right here are x values. These are the y values corresponding to them. Or the formula that we're going to use is f of B, if you just use some algebra to move this around, equals f of A plus B minus A f prime C. This one, you use when you get to like an upper level. We'll just stick with this one. What does this remind you of? It's just the slope formula. So the purpose of the mean value theorem is very simple. It's to find the, I'll give you a hint, the average of change, pretty much the slope, over A, from A to B is A, given interval. Okay? Now there are 4 steps you're going to use to do this, actually 5 steps. And let's discuss them. Step 1. You're going to find out what f of A is and what f of B is. All right, so the way you find that is, we'll go over that in a moment. You're going to use your x values to find your y values. Then you're going to plug it into f prime c to find the actual value. All right, so you're going to take these values and plug them into this equation. So you'll plug in your fa, fb, b and a, and you're going to find the value. Then you're going to derive. All right, you're going to derive the original equation to find out what f prime c equals. You're going to set the actual derivative from the equation to the numerical derivative you got from that equation. And then you're going to plug in x's to find the points of tangency. So you're going to solve for x there, and then you're going to plug in all your x's and find the points of tangency, which is the points where the graph intersects the function. Right? Seems like a lot, right? Really not that hard. So this right here would be your tangent line pretty much. That's your tangent line at c. Tangent line is the slope at this function, and as you move along, as you change c, your slope or your tangent is going to change. But we're going to actually find these tangent points. Right? I broke this down easy. Step 1. Find f of a, f of b. How do we do this actually? The way you do this is you're going to plug your a and b, which are always going to be given. You'll be given your interval into the original equation, and then it gives you these two answers. All right? Step 2. You're going to use this equation, and you're going to find a numerical value. You're going to plug in these two things that you just got, along with the b and a, which you were given. And that gives you a number value. Step 3. Take the original equation, and you're going to derive it. And that's going to give you your actual equation. Now you're going to take step 3, step 2, and 3 equal to each other. So you're going to take the derivative from plugging in the numbers, step 2, the value, which is a numerical value, and you're going to make it equal to the derivative of the equation. So you're going to have an equation equal a number. Okay, then what you're going to do after that is you're going to solve for x. All right, it's going to give you an x value. It may give you multiple x values. You're going to take the one x or all the x's you have, and you're going to plug them in to the original equation, and that's going to give you your y value, and that will give you your points of tangency. All right? So, and that's your answer. Your answer is the actual point. So let's take this for a spin and see if you guys can actually do this. Now, given 5 minus 4 over x, find all the values of c on the open interval. So, first step is to find f of 1 and f of 4, right? Because 1, 4 is my open interval from 1 to 4. So this right here, actually, you don't have this, but this is your graph. All right? So we're going from this point to this point. This interval right here, we're going to find out our tangent and secant. We're going to pretty much take everything out. So the way to find f of 1 is you take 1, you plug it into this equation. All right? My a is always first, my b is always second. So 5 minus 4, you plug in 1 for x. 5 minus 4 happens to be 1. So that is my f of 1. Now you can take my b, I plug it in. 5 minus 4 divided by 4. 5 minus 1 is 4. This is my f of a. This is my f of b. All right? We good so far? Awesome, awesome, awesome. Step 3. Happens after step 2, so let's do step 2. You're going to take your f of b, which is 4, your f of a, which is 1, your b, which is 4, and your a, which is 1, and plug them into this equation. 4 minus 1 divided by 4 minus 1. All right? 3 divided by 3 reduces to 1. So our numerical value of this derivative is 1. All right? Step 3, derive. You're going to derive this actual equation. So 5 minus 4 over x is the same as 5 minus 4x to the negative 1. Derivative of 5 is 0. Negative 4 times negative 1 is positive 4x to the negative 2. So this is the equation derivative of that question. Step 3, you're going to set these two equal to each other. Now, I would write this as 4 over x squared, and that's because that's a negative exponent, it goes in the denominator, just because it'll be easier in the end. You can do it now, or you can do it later. So, 4 over x squared equals 1. Or 1 equals 4 over x squared. It doesn't matter which way you equate. In order to solve for x squared, you multiply both sides by x squared. These cancel out, leaving you with x squared equals 4. Square root of 4 is plus or minus 2. So those are our x values. So that was the number one thing you wanted to find. You found your x values. So when your slope is this is your slope, all right? And then at these particular points, between these points, you're going to have it equal to this, and then these are going to be your two c's, pretty much. Take these two numbers, plug them into the original equation. You got x equals -2, and then you got x equals 2. Now, our interval is from 1 to 4. So -2 is not in this interval. You could solve it and cross it out later, or why waste your time, right? 2 is between these two numbers. That's the only one we really care about right now. -2 is over here on the graph somewhere, so it'd be like down, down, down. We don't care about them. So we take our 2, plug into the equation. 5 minus 4 divided by 2. 5 minus 2 is 3. All right, so our equation is 2, 3. I mean our point. All right? A little tough? Do a couple more and they become easier. Usually by the third one. All right, so if you look right here, we have 0.11, A, F of A. We have 0.44, B, F of B. And then 2, 3 right here. So the secant line goes through it. That was this right here, 4 over x squared. We pretty much take our secant line and we slide it to the C right here where the point, where the curve turns. That's what you're doing. And then we find that point. And that point we found to be 2, 3. All right, so we're using our secant line to find the tangent line, and we're just sliding it, and we're using our function to find the point. It's a little complex thing, but it's not too bad, right? Good. All right, try problem number 12. We got a bunch of problems today that we're done. All right, first step, find your f of a, f of b, a, b, f of -4. 3 times -4 minus 5 is -17. F of 3. 3 times 3 is 9 minus 5 is 4. All right? So we're going to take these numbers right now, my f of a and f of b, my a and my b, and I'm going to plug them all into this equation. So the way this works is f of b, 4 minus -17 over 3 minus -4. All right, and you get 21 divided by 7. 21 divided by 7 happens to be 3. All right, and then what we're going to do next, you're going to find the derivative. Derivative of 3x minus 5 is 3. Set these two equal to each other. Now this is a trick one. So you got 3 equals 3. So when does 3 equal 3? Always. All right, because there's no x here, no matter what I pick for x, it's always going to be 3 equals 3. Now, that means there are no critical points, okay? It means there are no tangent points. It means the whole line is one giant tangent point. So you don't have to plug anything in, and the reason for that is this is a linear equation. It's a straight line, so the tangent line is always the same. All right? So, why don't you guys try problem number 13? I'll do this. All right, so problem number 13. Maybe 20. All right, so way this works is you're going to plug in your two numbers, a and b. F of -2. -2 squared is 4. F of 1. 1 squared is 1. So you're going to take these things and you're going to plug them into the equation. You got f of b, which is 1, minus f of a is 4. 1 minus 4 over 1 minus -2. All right, and -3 over 3 is -1. Now you're going to derive the equation. Derivative of x squared is 2x. Pretty simple. Set these two pieces equal to each other. 2x equals -1. Divide both sides by 2 and x equals -1/2. All right? Once you find -1/2, plug it into the original equation to find your y value. -1/2 squared, negative number squared is positive, 1 squared is 1, 2 squared is 4. So it's 1/4. Our point is -1/2, 1/4. Right? Let's go to problem number 14. All right? F of 0 is 0 cubed, which is 0. F of b, f of 1, 1 cubed is 1. So f of b minus f of a over b minus a happens to be 1 divided by 1, which is 1. Derive this equation. Derivative of x cubed is 3x squared. Set these two equal to each other. 3x squared equals 1. Divide by 3. X squared equals 1/3. And your answer is the plus or minus square root of 1/3. You're going to take both of these, plug them into the equation. So now, square root of 1/3 equals, all right, let me tell you something real quick. You don't really need the negative square root of 1/3 because it doesn't fall on here. For those of you guys going to college, though, you do need to know how to reduce this. Square root of 1/3, you really don't want to square root the whole number because you don't want a radical in the denominator. So you would square the top and the bottom, right? Square root of 1 is 1. Square root of 3 is 3. But we don't want 3 in the denominator. So we multiply by radical 3 over radical 3. And you get radical 3 over 3. Right? Now, so your answer technically is plus or minus radical 3 over 3. Here's the deal, though. This is fine. But sometimes in multiple choice type questions, especially on entrance exams, you get something like this. These are the same. All right? This is probably written a little bit nicer. So, to find this thing, if I plugged in negative, as I told you before, not in the interval, so we don't even care about the negative. Don't waste your time. So we're going to deal with the positive one. Cubed root of radical 3 over 3 equals 3 radical 3 over 27, or radical 3 over 9. Most people, radical 3 over 3, radical 3 over 9, or, as you probably did, just use decimals, 0.6, 0.2. All right? 100% okay. Looks a little nicer, and it's more accurate if you use the radicals. Got it? Want to try another one? Good. Let's get to number 15. All right, let's go. F of negative 1. Negative 1 cubed, this is my A, this is my B. Negative 1 cubed plus 2 times negative 1 is negative 3. 1 cubed plus 2 times 1 is 3. And that is my f of b and my f of a. All right, so let's look. 3 minus negative 3 over 1 minus negative 1. 3 plus 3, 1 plus 1 is 6 divided by 2, which is 3. Derive this. 3x squared plus 2. Set them equal, right? 3 equals 3x squared plus 2. Subtract 2 from both sides. 1 equals 3x squared. Divide by 3. 1/3 equals x squared. And guess what we get as an answer? Plus or minus radical 1/3 again. But look at this time, they both fall within the interval, so we can use them both. And we said from the last problem, this reduces to radical 3 over 3. Take both these numbers, plug them in. Plug the negative 1 in. You get about, well, here, this is what you get. Negative 7 radical 3 over 9. All right. Plug the positive 1 in. You get 7 radical 3 over 9. All right. You can put them as decimals, though. Negative 0.58, as I said before. This equals negative 1.35. Negative, 58 hundredths and 1 in 35 hundredths. All right. There you go. All right. Almost there. Let's look at this problem. So, find the f of 0, f of 2. This would be homework. 0 to the 4th minus 8 times 0 is 0. 2 to the 4th minus 8 times 2 is 0. So, this is a strange one. 0 minus 0 over 2 minus 0. 0 over 2 is 0. Can your derivative equal 0? Of course it can. That's perfectly fine. Derive it. 4x to the 3rd minus 8. Take these two guys and they equal each other. 0 equals 4x cubed minus 8. Add 8 to both sides. Divide by 4. All right, so you get 2 equals x cubed. So your answer is the cubed root of 2. Now the reason this isn't plus or minus is because this is an odd exponent. Take your cubed root of 2, plug it into the original equation to find your point of tangency. Cubed root to the 4th minus 8 times cubed to the 2 gives you negative 7.56. So your answer is cubed root of 2, negative 7.56, or if you want just straight up decimal answers, 1 and 26 hundredths, and negative 7 and 56 hundredths. Right? Do now problem, I assume, right? Factoring. Ready? Factor a factor. So, factors of 2 are 1 and 2. Factors of negative 8 are negative 1 and 8. 1 times negative 1, 2 times 8. 16 minus 1 is 15. No good. Negative 2 and 4. So we go 1 times negative 2, 2 times 2 is 8. 8 minus 2 is 6. Now, these are close. The only difference is they have opposite signs. Alright, so let's just switch the signs. Take the negative and put it on the 4 instead of the 2. And look what happens. 1 times 2 is 2. 2 minus 8 is negative 6. And that's the good one. So 1 and 2 have to multiply. 1 and 2. 2 and negative 4. 2 and negative 4. And our answer becomes x minus 4, 2x plus 2. Alright, go for problem B. Factors of 7 are 1 and 7. Because this is positive and this is negative, both these answers are negative. So you got 1 and 3. So 1 times 1 is 1. 3 times 7 is 21. 21 plus 1 is 22. 3 and 1. 1 times 3 is 3. 3 plus 7 is 10. That gives you your 10. Alright? Now, so what happens is 1 times 3, your 1 is here, your 3 comes here. Okay? Your 7 is here, and your 1 is here. So your answer is x minus 1, 7x minus 3. Alright? So we're almost finished. We got about 5 minutes left. So, hopefully you got that. Alright, let's try problem number 17. And notice it goes quicker, and I'm just explaining this because you guys should be pausing and playing. So, f of 0, 0 to the 2/3 power is 0. F of 1, 1 to the 2/3 power is 1. Plug it in. 1 minus 0, 1 minus 0. 1 divided by 1 is 1. Alright? Derive. 2/3 x to the negative 1/3. Alright? Or 2/3, and then you have your cubed root of x on the bottom. Alright? Multiply both sides by 3. Actually, you can just multiply both sides by cubed root of x. Alright? Cancel these guys out. Cubed root of x equals 2/3. And then you're going to actually now cube both answers. 2 to the 3rd power is 8. 3 to the 3rd power is 27. Alright, 2 times 2 times 2. 3 times 2 times 3. Take your 8 over 27. Plug it into the original equation. So the cubed root of this is, once again, 2/3 squared is 4 over 9. There we go. So our answer is 8 over 27, 4/9, or if you use decimals, about 0.30 and 0.44. Alright, almost there. Alright, here we go again. Plug in negative 1. So when you plug in negative 1, you get negative 1 plus 1 over negative 1, 0 over negative 1 is 0. Plug in 2. You get 2 plus 1, which is 3, divided by 2, which is 1.5. Alright, plug them into this equation. F of b minus f of a, so 3/2 minus 0, which is 3/2. 2 minus negative 1, which is 3. Now 3/2 divided by 3 is actually 3 over 6, or 1/2. Alright? Good. Derive. What I would do here is, I would take both these numbers and just divide them by x. Alright, so x divided by x plus 1 over x. X divided by x is 1. So it's 1 plus x to the negative 1. Derivative of 1 is 0. This is negative x to the negative 2. Alright? Right here. Negative 1 over x squared. Because I just take this as a negative exponent, you move it to the denominator. Alright? Now, if you use the quotient rule instead, you could use either way. This would have been x plus 1 on top, x, and then 1 and 1, that's the derivatives. F prime g would have been x, g prime f would have been minus this. You would have got x minus 1 over x squared, which would have still gave you negative 1 over x squared. Both of these give you the same answer. And you're going to take that answer and you're going to set it equal to 1/2. You're going to multiply both sides by x squared. So that cancels out, leaving you with x squared over 2 equals -1. Multiply both sides by 2. All right, x squared equals -2. Now when I take the square root of -2, I get undefined as an answer. So what that actually means after all this work is, there are no answers, okay? X is undefined, okay? So there are no points. All right, 2 more problems. Right here, take your -7, plug it in. Radical 2 minus -7. Square root of 9 is 3. Square root of 2 minus 2 is 0. Square root of 0 is 0. All right, now you're going to take these numbers and you're going to put them into the equation. All right, you got 0 minus 3. You got 2 minus -7. You got -3 over 9, which is -1/3. Now what you're going to do is you're going to derive this problem to find out what the equation derivative is. Now when you do that, you got -2 minus x. So your u, chain rule, is the inside, 2 minus x. Your f of u is the square root of u, or u to the 1/2. U prime right here is -1, and f prime u is 1/2 u to the -1/2. All right? U prime times f prime u is how you do your problem. So it's -1 times 1/2 u to the -1/2. So it's -1/2, 2 minus x to the -1/2. All right? So you're going to set this equal to that. So -1/3 equals -1 over 2. 2 minus x is the square root. Because it's negative, it goes in the denominator. All right? In order to solve this, you're pretty much doing almost like a cross multiplication here. So you're going to turn both these positive. All right? You're going to multiply both sides by 2. Radical 2 plus that. These cancel out. And you're left with 2/3. Radical 2 minus x equals 1. Okay? You're going to divide or multiply both sides by the reciprocal here. Reciprocal of 2/3 is 3/2. So you get radical, see how they cancel out, 2 minus x equals 3/2. You're going to square both sides. This is just using algebra. 2 minus x equals 9/2. You're going to subtract 2. 9/2 minus 2, or 9/4 minus 2 is 1/4. You're going to multiply both sides by -1. You get x equals -1/4. So all this work to get a -1/4. Then you're going to take your -1/4, plug it in here. Radical 2 minus 1/4, which is the square root of 2 1/4, or the square root of 9 over 4, which is 3/2. So my answer is -1/4, 3/2, or -0.25, 1.25. All right? Ready? Big finish here. 4.2G, do now. So we're going to use the Rolle's theorem to find the critical points between the X-Intercepts. So this is a very easy problem. The X-Intercept, you set this original equation equal to 0. This is like a big review of everything we did. So x cubed plus 3/2 x squared minus 6x equals 0. You're going to take an x out of the equation, and then you're going to factor this. Now, x equals 0. Way you could factor this is you have to use the quadratic equation. All right, hopefully you use that. Give you a second to do it if you didn't. All right, negative b plus or minus the square root of b squared, I'm just turning it into 1.5, minus 4 times a, which is 1, times c, which is -6 over 2a. So this becomes negative 1.5 plus or minus 1.5 squared plus 24, square root of that plus that. So when you subtract these and you add these, and when you subtract them, you get negative 3.31. When you add this to this and divide by 2, you get 1.81. All right, those are my two X-intercepts. Now to find the critical points, you derive this. When you derive this, you get 3x squared plus 3x minus 6. You're going to divide a 3 out. X squared plus x minus 2 becomes x plus 2, x minus 1. You set both of those equal to 0. X plus 2 equals 0. X minus 1 equals 0. X equals -2. And x equals 1. So these are my two critical numbers. I take these two critical numbers, I plug them back into the original equation, and you get the points of -210. And when I plug 1 back into the equation, I get -3.5, and I get 1, -3.5. So my two y-intercepts, my two critical numbers. All right? And then finally, when we do the average change over the given interval for the next theorem, we take A, which is -3, B, which is 3, f of A, which is f of -3, we plug in here, you end up with 4.5 as the answer. F of B, we plug 3 in this equation, you end up with 22.5 as an answer. You take these four things, plug them into this equation, f of B minus f of A, divided by B minus A, and as an answer you get 18 divided by 6. 18 divided by 6 is 3. Now you derive this equation, and you get 3x squared. 3 halves times 2 is 3x minus 6. You have to take this equation and set it equal to 3. All right, remember, take these equal each other. You're going to subtract 3 from both sides, all right, to end up with a quadratic equation. You could divide the 3 out here. X squared plus x minus 3. Now, you can't factor this because there's no factors here, so you have to use your quadratic equation to find the x. Negative a, which is 1, plus or minus, b squared, which is 1, minus 4 times a times c over 2 times a. You get -1 plus square root of 13, because this becomes a positive divided by 2. So you get as your answers 1.3, or when you subtract the 2, -2.3. You're going to take both these answers because they both fall within the interval that we're talking about, and you're going to plug them into this equation. So 1.3, -3.1, -2.3 goes in here, and you get 9.6. All right, so these are our 2 points of tangency. So there you go. You just did everything we did in the chapter within 2 slides. All right, so that completes the lesson today. Hopefully you guys understand this. We will begin with the review tomorrow, and you'll have your test on 4.1 and 4.2, and hopefully you guys do wonderful. All right, so take care till tomorrow.